Okay, so the next topic of this chapter, or section of this chapter, is surface area. So we've got two different surface areas formulas, but basically one has to do with going around the x-axis and the other is being revolved around the y-axis. So let's just talk about the first one here. We'll deal with the x. All right, so again, so f of x is going to be a non-negative smooth curve. So it's not going to dip below the x-axis at all. Over some closed interval a to b. And the surface area of the surface of revolution formed by revolving the graph f of x around the x-axis is given below in that first surface area one right here. So it's going to go from, the integral is going to go from a to b, and we're going to take 2 pi and multiply it by the function itself, and then multiply that by our formula for the arc length. So this part here, let's do maybe this part here you should recognize as the formula for arc length. So what's added? Well, it's going to be 2 pi and then the actual function itself. So we're multiplying it again by the function. All right, so let's take a look down here. So in your book it says for the following exercises, find the surface area of the volume generated when the following curves revolve around the x-axis. If you cannot evaluate the integral, use your calculator to approximate it. I'm not going to give you those sort of problems. So this one here is one that we can certainly evaluate. Now let's use the surface area. Again, we're going around the x-axis, so here, our lower bound is 0, our upper bound is 1, so 0 to 1. We're going to write 2 pi, because that's part of our formula. The actual function itself is x cubed, and then we have the square root of 1 plus the derivative of that, so d dx of x cubed, all squared. We can pull the 2 pi out. Leave the x cubed here, and then solve for what's under the radical. So that's 1 plus, well, the derivative of x cubed is just 3x squared. And that we'll have to square in a moment. This is 1 plus 9x to the 4th. And here we can make an easy substitution. So let's do that. Here we're going to have u equal 1 plus 9x to the 4th, which makes du equal to 36x cubed. Right? So we don't have a 36, and excuse me, we're going to add a dx here, of course. So this means that we've got the 36. So x cubed dx equals du over 36. So the 36 needs to be used as well. So let's do that. So 2 pi over this 36, and that's this 36 here. The x cubed is taken out, so we don't have this guy anymore because we're removing x cubed and dx with this. So that's just the square root of u, du. And we probably should leave these off because we're changing the variable. We're not doing that, so it'll just be u to the 1/2 du. We'll evaluate this, change it back to the x, and then put in the 0, 1. So 2 over 36 is really just 1 over 18, so this is pi by 18. And this integral here is 1 over 1/2 plus 1, u to the 3/2. Okay, so still pi by 18. And then we have 1 over 3/2, which is really 2/3. And u, we're going to replace back what we have. So this is going to be 1 plus 9x to the 4th, all to the 3/2. And all of this is evaluated from 0 to 1. All right, so now we have to do the actual evaluation here. And we can break this up into 2 pieces. This 3/2. Actually, let's move the 2/3 out real quick. So we can cancel the 2 and the 18, which gives us pi by 9 times 1/3. So that gives us pi by 27. That's the combination of these guys here. We multiply through, we cancel the 2 and the 18, and so forth. And then we can break this up here. It's probably just easier to break this guy up. So this will be 1 plus 9x to the 4th times the square root of 1 plus 9x to the 4th. That's what 3/2 is. Pull out 1, and then we're left with 1/2. All right, and then we get here, we plug in a 1, that gives us 10. 1 plus 9, x to the 4th. 1 to the 4th is just 1. So that's 10 root 10. And then minus 1, because if we put in the 0, that cancels. 1 root 1, right? Which is really just 1. So this equals pi by 27 times 10 root 10 minus 1. And this form is just fine. You can leave it as is.